Hello, everyone. Welcome to the Parsons Technical Webinar Series. I'll be your host today, Jessica Bennett. Today, we have with us David Fleming, who will be presenting on aqueous film forming foam cleanout and treatment of PFAS in water using PerfluorAd. So a few housekeeping items first, if we can go to the next slide. So we'll be keeping all phone lines muted throughout the presentation to keep any background noise down. If you have any questions throughout the webinar, you can enter them into the chat feature at any time, or wait until the end of the webinar and you can either ask them in the chat then or raise your hand if you want to ask a question live. This webinar is being recorded and will be available on the Parsons YouTube channel in the next few days if you want to come back and review anything that you might have missed. Next slide, please. So just a brief agenda, I'll introduce our guest speaker, David Fleming, followed by a core value moment, and then we'll complete with a technical presentation and wrap up at the end with questions and answers. Next slide, please. So David has 37 years of experience in environmental health consulting and remediation. He specializes in environmental site remediation and commercializing soil and water treatment technologies, including thermal and PerfluorAd for AFFF cleanout and treatment of PFAS in water. He's also the founder and employee owner of the TRG group. And with that, I will hand it off to Dan Griffiths, our Innovation and Technology Director, who will present a core value moment before we get into the technical presentation.
Thanks, Jess. So Parsons has 6 core values. I think most appropriately for the content today, I'm going to focus on the innovation core value. David, can you go to the next slide? Thank you. So Parsons is known in the industry as an innovator. We're innovating in terms of developing new solutions for complex technical challenges on our sites, as well as technical innovation in terms of developing new technologies and new capabilities, both internally and externally. You can see in the center a list of recent innovative technology-driven projects that we've completed or are completing. And on the right-hand side of this slide, you'll see a series of recent patents that have been awarded for technologies that were developed primarily internally in our internal R&D lab in Syracuse. A few of these were actually developed in collaboration with others. A key point to innovation, and you'll see this over and over, is that while internal innovation and technical excellence is key and critical, we actually develop a lot of our strategies and our technologies through external collaboration. We collaborate a lot with external parties in the industry, TRS being one of our key collaboration partners, but we also collaborate with universities and academia to bring the best possible solution to our clients in terms of approaches as well as technologies. Collaboration is absolutely critical to innovation. And with that, I'll hand this off to David. David, thanks very much for your time and effort, and thanks for bringing your cool technical content to this presentation.
Yeah, sure. Thank you all for the opportunity. Hello, everyone. I want just to quickly give you a little bit of background about our company before I get started into this and give you a little feel for what I'm going to be covering. I was one of the founders of the TRS group. We started the company this is our 25th year in business. Started the company 25 years ago to commercialize in situ thermal remediation technology, and that continues to be our core business for remediation of soil and groundwater impacted by mostly organics, also PFAS now in soil. We've got patents for electrical resistance heating and thermal conduction heating. A couple of years ago, through our work in Europe, and a partner of ours called Martin Cornelissen in Europe, he started the Cornelissen water treatment company. We learned about his efforts and success in creating the PerfluorAd technology, which is a surfactant-based technology that can clean out AFFF from the inner wetted surface of a firefighting system. I'm going to go through that and show you how that works. But also, the technology can treat PFAS in water, and we'll talk a little bit more about that too. Soon after we learned about Martin doing this in Europe, we came to a license agreement with Martin to bring the technology into North America for the specific purpose of AFFF cleanout in firefighting systems, and now we are the exclusive licensee in North America for that purpose. So that's a little bit of a background, and I was going to walk you through First of all, why are people even doing this? What are the differences between some of the vehicles that we're working on, the mobile vehicles you see here in this picture, and then describe how the technology works and show you some examples of where we've applied it. What you're looking at here, the top picture in in this slide is an aircraft rescue firefighting truck, or an ARFF vehicle. And down below in the red is what's called a structural firefighting truck. And the difference between these two are the top one, the ARFF, is for airport, putting out fires at airports. They're bigger than the structural trucks. They're not able to go on the road, a regular road, so they keep them in the airport, or if they have to, they'll truck them around on a trailer. But they're designed to go very quick, very fast, out to a fire, an airplane fire or whatever on the airport, and put it out very quickly. And so they have larger tanks. They're bigger. They're outfitted with the turrets and the cannons, as you see on that one there. And down below, the structural truck is more of a typical firefighting vehicle that you'd see at a municipal fire department in your local community or something like that. That's the difference. We're cleaning them both out. Most of the work we've been doing are on ARFF cleanouts, though, for airports, major airports, we'll talk about here in a minute. But the question is, why are people even interested in doing this? And one of the big reasons and this is pretty much what I hear from fire chiefs and other people involved in operations at airports, is because they want to protect their firefighters and try to remove the PFAS, exposure as best they can through cleaning out AFFF and protect their firefighters, number one. And also the environmental aspect of it, health and safety, and the cleanliness of the environment, remove as much PFAS as possible out of the environment. AFFF is no longer being manufactured in the US, so there's a big reason why they're transitioning in the process of this transition, right, where the new fluorine-free foams that have been, studied and come to market now pass the mil spec or part of the mil spec and have these different products available. They're a much less PFAS concentration in those newer foams. And there's a liability management aspect of this too, because insurance companies are less inclined, as I'm hearing, to pay for a spill or some type of a release in an airport, AFFF type release. So there's that aspect of it too, managing your liability. And then we're also hearing that if you really need to thoroughly clean out these systems before you transition to the new F3 foam, fluorine-free foams, to really optimize the operations of the system with the new foam. We have heard, not very much happening out there, but a couple of instances where thorough cleaning did not occur. The new foam was put into it, and it did not operate. The system did not operate the way that it was expected to. So they had to step back and redo it, re-clean it. And that was not with our process. It was cleaned with a water solution, so it did not thoroughly clean the system. We'll get into that a little bit more as we get further into this. Yeah, so it does improve performance, cleaning out thoroughly the AFFF before you transition to the F3, and then the cost of actually cleaning out these systems is a fraction of the cost of replacing the system. Replacing one of these trucks, ARFF trucks, for example, is $1.2, $1.5 million, and what we're doing is a fraction of that. So PerfluorAd is the name of the technology. It's a plant-based oleic acid you see here on the left in this vial. It's a surfactant, essentially. It's a soap, and it is biodegradable. And I'm going to show you a quick video here to show you how this works. When we add the PerfluorAd to the PFAS impacted water, which is the example in the video, there's a stir that's happening inside that flask. There's through a weak ionic bond that's created between the PFAS and the PerfluorAd, a particle's formed, a flock, if you will. And then once that's been formed, we're able to filter it out of the water. And you can see over on the far right that that's the end result of this laboratory example, as you've got your filtered or dried flocculant on the pleated sheet over there. And this is a weak ionic bond that's happening. So the PerfluorAd is a positively charged molecule, and the PFAS, most of them we're targeting, are negatively charged. So when the two of those come into contact for a short period of time, it forms this particle. And it's a pretty stable particle as well. And we'll show you more about this, how this works as we move on here. What we're doing first is we're removing the AFFF concentrate out of the mobile system. By the way, this also works in fixed systems, and I have some data to show you on fixed systems as well, like storage, AFFF storage tanks, and fixed systems in a hangar or a building, fire suppression systems. But for this example, this is a truck. So we're removing the concentrate from this truck. Same for the fixed system. You remove that AFFF concentrate. That's stored on site for off-site disposal. We're not treating that. And then we do a first potable water rinse of the vehicle, and we capture that rinse, our rinsate material as well. And that also is too high in PFAS concentration for us to treat economically and in a timely way with PerfluorAd. So both of those two streams are stored on site and then disposed off site. And then after we've done that, we create our solution in this mixing tank, which is potable water that's heated to about 120 degrees Fahrenheit maximum temperature. PerfluorAd's added into that mixing tank. That gets stirred up so it's very homogenized, and then that gets flushed through the vehicle 3 to 5 times, depending on what we're visually seeing in terms of foam formation. I'll talk a little bit more about that in a minute too. Each of those flushes is followed by a potable water rinse. So we're capturing that potable water rinse in those flushes that we send through the vehicle. And by the way, we're not just cleaning the AFFF tank in the truck. We're cleaning the piping, anything that's been impacted by AFFF, with the exception of a rubber hose. We're not cleaning out the hoses. Those are typically replaced. But we're cleaning the AFFF tank, we're cleaning the piping, we're cleaning the cannons, the turrets, we're cleaning the undercarriage sprinklers. So we're doing a really thorough cleaning. And we're also agitating that flush material, that solution as it's in the vehicle, as best we can, with movement if we have to move the truck around, or if we're using any type of pressure washing or scrubbing with brushes. There's a lot of physical activity, agitation that occurs too. And then once that flush and rinse material has gone through the system, it's then captured back in the mixing tank. PerfluorAd's added into the mixing tank again to create that flocculating process. And then after that's been accomplished, that material goes into the sedimentation tank. You see there, the blue tank. It's cone-shaped, and through gravity separation, the sludge or the PFAS and PerfluorAd concentrated material comes out the bottom of it. And that material is also stored on site for off-site disposal. We're not treating that any further than the process it's already been through. And then once you move from sedimentation to these bag filters, filtration there, those gray columns that you see there, that's our bag filters. And those bag filters are designed to remove any remaining flocks or particles out of the water. And then those are dried and also disposed off site. And then the following resulting water is treated with carbon or ion exchange resin to polish it so that we can discharge it to the sewer if we have permission to do that from the regulatory authorities. And that's one of the big advantages of this technique, is that we're cleaning out the system, but we're also we can treat the rinsate with the same process, allowing us to discharge on site, assuming we get down to the objectives that we've been told we need to for discharge, and the local authority and the customer are willing to let us do that. Saves money. You don't have to ship the material off site for disposal. Here's a picture of what we call our mobile batch treatment system, and this is our second generation batch treatment system. The mixing tank is on the far right, the steel tank. That's got a heating component to it as well, where we can heat up that water. Then the two white tanks are sedimentation tanks, poly sedimentation tanks with stirrers in the top of them. And then on the far left is our treatment, filtration and treatment skid with two 200-pound granular activated carbon vessels on the front end of it. And then on the back end of it are bag filters that you can just see the top of that one right there. And then in the far back, you can see these Baker tanks, 20,000 gallon Baker tanks. We store rinsate in these Baker tanks until it's treated rinsate, until we're able to get our analytical results back that confirm we've reached the discharge objectives requirements before we discharge that to the sewer. And I did not mention, by the way, that when we take our first sample in the beginning of this from the first potable water rinse in the vehicle, take that sample, send it to the analytical lab, that becomes our baseline PFAS concentration. And then once we believe we're done cleaning, we take a final sample, compare the two, and we can, report on the results. Here's another quick video that shows the field operations, how this actually happens in the field. So we see here first, this is our field operations manager, Steve Pistol. He's mixing the PerfluorAd in a heated 5-gallon bucket, getting it really well homogenized. And then after he's done that, he'll take about 100 milliliter cup of it and walk it over to the mixing tank and pour it in there. This is heated water inside the mixing tank. Pour the PerfluorAd in there, get that solution that will ultimately flush through the truck in this case. There's a stirring that's going on. You can see a little bit of agitation to the water, and there's a little bit of a color change to more of a milky white once that's prepared. And then once that's been prepared, we'll use the venturis in the truck, pumps, external, internal, to flush that solution through the truck, and then capture that rinsate here in the tank that comes back from the truck. And you can see the foam formation there on the surface of the water. That's a visual indicator of when we're done. When there's no more foam formation that's happening on the surface of that, then we know that we're done. And then he's cleaning the tank out here with the solution. And then that rinsate goes over to the sedimentation tanks where the sludge, in this case, PFAS and PerfluorAd, is being, from those sedimentation tanks, is then put into a 55-gallon drum for offsite disposal. And I wanted to touch on the foam formation. We're looking down in the mixing tank here. I mentioned foam formation is a visual indicator of when we're done. And the reason that we do that is because analytical turnaround times are too long for us to wait, keep the truck out of service, keep our equipment on site that's not being used. And so it's turned out to be very accurate, and we've proven it with the analytical results. No more foam formation on the surface of the water is telling us we've gotten it as clean as we're going to get it. And also what you're looking at here inside this tank is a very dirty foam, PFAS, dirt particles coming out of the system. And that's after the first potable water rinse and the first PerfluorAd flush. The point is, it takes more than just a water rinse and more than just one flush of the PerfluorAd solution to get the system clean. And it takes a number of those. And we try to, minimize the amount of rinsate that we're creating, and actually looking at ways of recycling rinsate too, to lower the volume of that material. But that's just a really good picture, I thought, that helped tell the story there. So you're looking at the sedimentation tank connections, the red hoses there, stirring system, the candy cane metal pipes on the far right. That's the pipes that are conveying the material back and forth from the truck. And then, as I mentioned earlier too, we're heating that water. So this slide is showing you an early test that we did for a major West Coast airport, where we had the opportunity to compare using water alone to clean out a truck versus using the PerfluorAd process. And these are the results of that little study that we did. This is in nanograms per liter, total PFAS. The first green bar you see is our baseline concentration, just over 60,000 nanograms per liter, total PFAS. And this, by the way, we were using EPA method 537, which was 31 PFAS compounds, I believe. And then the middle green bar, the higher bar there, that's the total PFAS concentrations after doing a triple water rinse. And it increased by about 10%, the total PFAS did, which surprised everyone. And then after that, we did the PerfluorAd process. We did actually 4 or 5 flushes of the PerfluorAd solution, followed by potable water rinses. And lo and behold, we got really good results. In fact, we got down to non-detect for PFOS, PFOA, which was the goal of this project, so that the customer could discharge the rinsate on site to their on-site sewer. So point being, water alone is not sufficient to clean these systems out. And if you're just using water alone, you're running the risk of your system not operating correctly with the new F3 in it, and perhaps having high PFAS concentrations that are still potentially exposing firefighters and the public. So my first project I want to share with you, we did this at the Seattle-Tacoma International Airport last fall, and these are the results, at least from one of the trucks that we did that I'm going to show you. We did 10 trucks here, and one of the interesting, I think, and really nice elements of this project was really to the credit of Chief Krause, Randy Krause, fire chief at the Seattle Airport, and Megan King, the environmental manager for the Port of Seattle. They had the vision together to create a regional cleanout center at the Seattle Airport Firehouse, and then open that up to other local airports to bring their trucks in there so they could take advantage of some economies of scale that we can talk about later too. With 10 trucks versus 5 for Seattle, and then there was King County Airport from Boeing Field brought over 3 trucks, and Bellingham International Airport brought over 2. And had they not done that, their price for per truck clean out would have been much higher than what we were able to give them here, doing them at the airport. And at the Seattle Airport, there were Oshkosh and Rosenbauer trucks, one E1 truck. We did 10 trucks, as I mentioned. It took about 7 days per truck to clean these out. 2 of the main reasons we were told that we were selected for this project was our focus on and plan for waste minimization, generating, using rinse-aid, recycling it, so we do bring down the volume of that rinse-aid produced, and also treating the rinse-aid on site so they could discharge it to the sewer. Saved them a lot of money, as you'll see in a minute. This is a Rosenbauer, the first Rosenbauer we did, results we're looking at here. That's the Seattle Airport. So this is in nanograms per liter, and this is for 6 PFAS compounds that you see over here on the far right. PFNA, 6,2-FTS, PFOS, PFOA, and on and on. The initial concentrations on the far left are there with the high bars, as you might imagine. The final concentrations in the middle, and then the percent reduction that represents for these 6 compounds. I chose these 6 compounds out of the list, the 537 list of 31, because the 5 of them, not the 6,2-FTS, are the 5, at least at this time, EPA has said they're going to, regulate under the drinking water standard. And they'll set MCLs for them, which are still in the process of doing that, I believe. It has not been promulgated just yet. But then the 6,2-FTS I added in here because that one tends to be a difficult compound to clean out, and we did a good job of it there, and I wanted to share that as well. So this data here that we're looking at is designed to present, what's the difference between from a volume standpoint, generating rinse-aid, and a cost standpoint of getting either disposing of it on site, discharging it to the sewer, or disposing of it off site. So the first line you see in the table, PerfluorAd, we generated more rinse-aid, 80,000 gallons, but we were able to treat that rinse-aid and dispose of it on site for pennies, really, per gallon, $8,000. Whereas triple rinse below that, you generate less volume of rinse-aid, but your disposal costs are much higher. And that range of disposal is based on offsite disposal, incinerator, landfill, 200,000 up to $1 million if you're doing total destruction offsite of the PFAS. And it does not include, by the way, many other fees that are added on to those costs from waste disposal companies. So big difference. So that was Seattle. This is LAX. We also completed this job for LAX, Los Angeles World Airports. It was the client. The 2 airports were Los Angeles International as well as Van Nuys airports. And this project was completed in December of last year. Similar setup, a couple more trucks, Oshkosh, Rosenbauers, and an E1, 13 ARFs, and 1 storage tank. And we're getting better and quicker at cleaning these trucks out. We're trying to minimize the amount of time that one of these trucks is taken out of service so that the airport is able to maintain their index. And again, we were selected here based on waste minimization and also being able to treat the rinse-aid on site for discharge to the sewer. And by the way, Seattle was the first project where we were able to, on a commercial scale, able to work with the local discharge authority, happened to be King County Industrial Wastewater, I believe. They allowed us to discharge, they were the ones who actually were able to provide that authority to discharge on site. And at LAX, it was the local sewer authority. So those are the first two projects where we've been able to do that. And it's a big value added for this technology because it saves that money versus offsite disposal. This is the data for all 13 trucks and the one tank that we cleaned out for LAX and Van Nuys airports. This is in total PFAS, as you see, and then you can see down below here, truck 1 through 13 with that tank over here. The blue columns, the tallest ones, are the baseline concentrations. And then the yellow are the final, and the green is the percent removal. And I've added the percent numbers here at each truck and tank so you can see what those percentages was. But it averaged out about 99.92% PFAS removal from all of these apparatus. And I have this data point also for the rinsate discharge. This is one tank out of several showing you in total PFAS pre-treatment in the first bar here, just over 2 million nanograms per liter. Post-treatment in the middle, then to 10.5 nanograms per liter, and the large percent reduction that we achieved here so they could discharge that rinsate to the sewer. And then cleaning fixed systems. So that was mobile systems. Now I'm going to touch on cleaning fixed systems. And by the way, with Corneliussen's work in Europe and ours in North America, mostly the United States, we have cleaned out 100 combined, the two companies combined, 150 firefighting trucks and about 50 fixed systems. Most of those are Corneliussen's. We've done roughly 60 truck cleanouts and just a couple fixed systems, small systems. So data I'm going to show you, these examples are from Corneliussen's experience cleaning fixed systems in Germany, mostly. And it's the same setup, really. You remove the concentrate out of the system, in this case, an airplane hangar, from the storage tank and wherever else there may be any AFFF concentrate that you can get out of the system. You run the process through only the components of the system that have been impacted by AFFF, right? That tends to be the storage tank, the proportioner, and maybe some small sections of piping, but not the whole system, because oftentimes the whole system has not been impacted by AFFF, but it does happen. So similar type of a setup as with a mobile system. And cleaning out these control rooms, as I mentioned, storage tanks, bladders, the proportioner piping, some discharge points perhaps, but not the entire system if it has not been impacted by AFFF. So we're really coordinating with the service team. We partner with different fire engineering companies that have actually been designing or have designed and perhaps constructed these systems. It's important to work and coordinate with them from their experience and their knowledge of the system. Some cases we remove the bladders if it's a bladder tank and clean that out. We'll use defoamer and a water flush to minimize the amount of foam that's generated. Recirculating the PerfluorAd solution in these systems, the parts of the systems that we're focused on cleaning out, similar to what we do in a mobile system. Multiple flushes followed by water rinses, agitation as best we can, and then treat the rinsate on site so we can discharge that rinsate. And it is really a contact game versus pressure. We want to make sure where the AFFF has been in contact with the system on the interwetted system part of that system and contact the PerfluorAd solution with that part of the system. So here's some results. And this first one is the storage tank system at a chemical plant in total PFAS nanograms per liter. See the beginning concentrations for tank 1 in the blue and tank 2 in the orange. Final concentrations and the percent reduction that represents for cleaning out these tanks. And then another tank farm example showing you beginning, final, and percent reduction for both cleaning out a pipeline, which is the orange, and the blue is the tank, for close to 99% removal of the total PFAS at the tank farm. And then in a hanger system, again, the tank, the proportioner, very small part of the pipeline, beginning concentrations in the blue east pipeline, west pipeline in the orange, final concentrations, and 99+% removal of the total PFAS out of that system as well. So key points, I hope I conveyed to you all, and if not, I'll convey them here. So this is an environmentally safe solution, right? It's a biodegradable oleic acid surfactant that's used with heated water and agitation and flushing and rinsing, followed by rinsing, to clean out the system 99% plus. We can achieve low PFAS objectives as we've shown. We're doing now our, another major airport, two actually, one in California and one in Colorado. We have not observed rebound on a commercial project. It has been looked at least by Chief Krause. He has a plan at Seattle Airport to look at the rebound in different intervals throughout a year, the rest of this year. He's looked at 2 months following cleanout already. There was no change in the PFAS concentration, so no rebound there. And I say no rebound on a commercial cleanout because we did see rebound in a ESTCP project that we did a couple of years ago at Tyndall Air Force Base. And there's extenuating circumstances that you have to account for and understand. I'm not going to go through all those right now, but happy to talk about them later if somebody's interested in hearing about it. But that's been the case. We are able to treat, not only clean out the system, but provide rinsate treatment and disposal of the rinsate on site. It saves a lot of money. It's really the way to go if you can get permission from the local authority. So far, we've been able to do this in 3 states: Indiana, Washington, and California. And I do see that growing, but sometimes, it's not possible and you have to do offsite disposal. But that is one of the big values of what we're doing, is minimizing the waste that's generated and disposed of offsite, helping to manage liability by disposing of less volume of waste offsite. There are economies of scale here. If we can get to it like we did at the Seattle airport, set our equipment and staff in one place and not move it and bring trucks to us, we can get the price down quite a bit, actually, for multiple vehicles. If it's a one-off type of a clean out, the price is going to be higher. If it's 10, the price is going to be a lot lower per vehicle. And then we have a national and global service team to support customers really around the world in doing this type of work. Anybody have any questions?
Thank you, Dave. That was a great presentation on the latest in AFFF cleanout and ways to reduce the risk and liability associated with it. If there are any questions, you can enter into the chat at this point, or if you want to ask it live, you can raise your hand and we'll have you ask it live. I see there's already a few questions in the chat. So the first one is from Richard Steinberg. What is commonly your PTO discharge PFAS concentration goals that you referenced? How low?
So that's different for each state or location that we've encountered. As I mentioned, 3 states: Indiana, Washington, and California. And Indiana was non-detect, had to be non-detect total PFAS. How do we do that? We might have to run it through an additional passes through carbon to get it down to that level, but we were able to do that. In Washington, it was much higher than that. And the reason it was higher in Washington was because, and I don't know the exact number, but the airport had authority to discharge AFFF concentrate from firefighting activities in their permit. And, what we had explained to the authority was that we're going to have a lot lower concentration of PFAS than it would be in the concentrate. So, that was pretty much talked about. But I don't know the final discharge limits, but much, much lower than what was in the concentrate. And at California, you saw that number. It was just 10.3 nanograms per liter total PFAS. And that was our best result. The other results for the other tanks were slightly higher than that, but not by much. So as you can see, they're different from so far in each of those states. And the key in doing this is to work with planning ahead, right? Have a plan in place, but working with the local authority, whoever it may be, whether it's a state authority, local authority, whatever, but working with them ahead of time, letting them know what you're going to do, so that they're part of the process and planning for this, and they agree ahead of time, what is the plan, and move forward from there.
Thanks, David. And a second question that's related from Richard Steinberg was, does your process include the carbon or ion exchange treatment, or is that a third-party treatment?
No, it does include filtration, an amount of it. And then we also have a line item for additional passes. If we need to do additional filtration, we'll have a line item for what that would cost. But the initial pricing does include that as well.
Okay, our next question is from Patty Nealis. Have you sampled any of the cleaned AFFFs for rebound? I know you mentioned that a bit in your conclusion, but if maybe if there's anything else you want to add or expand on with that.
There, we've only got the one project where that's part of the plan for the future for the Seattle airport. Chief Krause wanted to look at rebound in 3 different intervals, from what I understand: 2 months, 6 months, and 12 months. They've done the 2-month. I haven't gotten that data. I've asked for it. I'm trying to get it. Also trying to get the procedures, and eventually I'll get them and be happy to share them with you, as long as the client will allow, which I think they will. They've been very open about it. But other than that, we don't have any other rebound data yet. I think we will eventually. It's still fairly new, the whole Cleanout market. So I assume we're going to have it as time goes on.
Okay, the next question is from Jeffrey Dietrich. Are you able to treat the initial AFFF concentrate with PerfluorAd to eliminate the need for all site disposal of the AFFF concentrate, similar to the rinsate?
Yes and no. I mean, you could, but it would take a tremendous amount of dilution, and therefore create a lot more volume of waste, right? So from a economical and time standpoint, we are not doing that. Because it's less money to ship it off site. Yep, there's liability with that, but less money. And yeah, it's just, so far that's been the way customers have wanted to do it. But I mean, in practice, it's possible, but you would have to dilute the AFFF concentrate. And I don't know, what ratio, but a lot of water to the concentrate, and, create a lot more volume.
Okay, the next question is from Jason Price. How is TRS different than other companies offering cleanout services?
Well, so I tried to get this across, is the really our focus is to minimize the amount of waste that's generated on site and that is ultimately disposed of off site. And the way we're doing that is, as time goes on, getting better at using less volume of rinsate and flush material. So we're creating less volume on the back end to treat it, but we can treat that on site, the rinsate, not the concentrate, and not that first potable water rinse. But once we're into the PerfluorAd process and we've created that rinsate, we can treat that and discharge with permission from the authorities clean water to the sewer. The other thing that's different about us and what we're doing is we're cleaning not just the AFFF tank. We're cleaning everything that's been impacted by AFFF, with the exception of hoses, rubber hoses. We're not cleaning those. Those should be replaced. But we are cleaning the piping inside the vehicle or the system, cleaning the tank. We're cleaning the turrets and the cannons. We're cleaning the undercarriage sprinklers, assuming they've all been impacted by AFFF. We are cleaning all of those thoroughly, and not just the tank. And so I've heard that there are some companies that are cleaning just the tank. So those are the 2 big differences: being able to treat the rinsate on site and discharge to the sewer with permission, and cleaning all aspects of the vehicle that have been impacted by AFFF.
Okay, our next question is from Emma Sauer. For higher PFAS concentrations, was more perfluoride needed to achieve acceptable PFAS levels? And if so, how much more was needed?
I don't have a specific answer to that, but the general answer is yes, more perfluoride. How much exactly, I don't know. But you saw the amount that was used in that video, 100 milliliter vial or container, a beaker of perfluoride. So it's not a lot of perfluoride that's used to create this flocculating process. But I don't know any more specifics than that. So I don't think I can fully answer your question, but hopefully that helps.
Okay, next question is from Richard Steinberg. Can you give us an idea of the average cost per truck if you set up to do 5 trucks versus your 10 truck example?
Yeah, I can give you a cost range. So based on our experience, if you're doing a one-off type of clean out one truck, and a lot of the cost is in mobbing and demobbing and travel and labor. So typically we're seeing on the order of 70,000 per vehicle, maybe a little bit higher depending on where it is in the country, for a one-off. But if you've got like 10 or 13 or 22, that price comes down dramatically, by half, generally a little bit less than half. So in Seattle, it was mid 40s per truck. So that gives you some idea, economies of scale. 10 trucks, maybe 5 would be a little bit higher than that, maybe 50,000, low 50s, but one-offs, upwards of 70 plus, and 10 or more below 50,000 per truck.
Okay, if anybody else has any more questions, you feel free to enter in the chat while we go to the next slide.
Okay.
So our next webinar will be on February 20th on the thermal desorption of 2,000 cubic yards of PFAS impacted soil, presented by Mark Kluger. It will be at the same time, 12:30 to 1:30 p.m. Eastern. And that invite will be available through the same methods this one was provided today. It'll be on our LinkedIn channel, as well as sent out to anyone who's on our mailing list. If anyone has any other questions, feel free to reach out to David directly, or you can follow up with us if you don't have his contact information or didn't catch it on the last slide. Thank you to everyone who joined us today, and we hope to see you again in February.
Thank you all.